Lesson number 11. How much reacts? By the end of this lesson, you should be able to explain that to produce required amounts of product, chemists must be able to calculate how much reactant to use, and calculate the masses of substances involved in reactions given the relevant equation. Acids can be neutralized by a base to form a salt and water. For example, sulfuric acid reacts with sodium carbonate to form the salt sodium sulfate, water, and also carbon dioxide. If you don't add enough of the reactant sodium carbonate, there will still be some acid left, so the solution at the end will not be neutral. If you add too much sodium carbonate, the end solution will be alkaline. So you need to calculate the amount of acid and base needed to react completely. To do this, you need to know the amount of acid present and the balanced formula equation for the reaction. The calculation will involve the following steps. Step 1. Write the balanced formula equation. Step 2. Find the mole ratios of substances in the equation. Step 3. Change the units as required. And Step 4. Solve the problem. Here is a worked example. What mass of sodium carbonate is needed to exactly neutralize 2.45 grams of sulfuric acid? The relative formula mass for sulfuric acid is 98. The relative formula mass for sodium carbonate is 106. The balanced equation is 1 molecule of sodium carbonate plus 1 molecule of sulfuric acid goes to 1 molecule of sodium sulfate plus 1 molecule of water plus 1 molecule of carbon dioxide. The mole ratios of acid to sodium carbonate are therefore 1 to 1. Changing the units, 98 grams of sulfuric acid is equivalent to 106 grams of sodium carbonate. Solving the problem, therefore, 1 gram of sulfuric acid is equivalent to 106 divided by 98 grams of sodium carbonate. 2.5 grams of sulfuric acid will therefore be 2.5 times 106 divided by 98, which equals 2.65 grams of sodium carbonate. 2.65 grams of sodium carbonate is needed to neutralize the acid. You can calculate the mass of solid formed in precipitation reactions in a similar way. For example, if sodium carbonate and silver nitrate solutions are added together, a precipitate of silver carbonate is formed. To calculate the mass of precipitate formed, you need to know the mass of silver nitrate reacting and the balanced formula equation. The sodium carbonate must be added in excess, so that all the silver nitrate reacts. Here is a worked example. What mass of silver carbonate will precipitate when excess sodium carbonate is added to a solution containing 4.25 grams of silver nitrate? The relative formula mass for silver nitrate is 170 grams. 2 moles of that would therefore be 340 grams. Silver carbonate has a relative formula mass of 276. The balanced equation is 1 molecule of sodium carbonate plus 2 molecules of silver nitrate goes to 1 molecule of silver carbonate plus 2 molecules of sodium nitrate. The mole ratios are therefore 2 moles of silver nitrate is equivalent to 1 mole of silver carbonate. Changing the units, that would be 340 grams of silver nitrate being equivalent to 276 grams of silver carbonate. Solving the problem, 1 gram of silver nitrate will therefore be 276 divided by 340 grams of silver carbonate. 4.25 grams of silver nitrate is equivalent to 4.25 times 276 divided by 340, which equals 3.45 grams of silver carbonate. 3.45 grams of silver carbonate is precipitated in this reaction.